All right, so boys and girls, when we have a parabola, stop, we're going to do some word problems now, and all these word problems are going to involve maximums and minimums. So think about a parabola opening up. You now know how to find the vertex of that parabola. It's either in vertex form or you do negative b over 2a, right? And you find the vertex. Well, if the parabola opens up, the vertex is the minimum. If the parabola opens down, the vertex is the maximum. So when you build an equation and the word problem says, find the maximum area, or whatever it says, all you need to do is find the vertex. So you already know how to do that. So hopefully these will be easy. So the first one we're doing is number 54. Among all the rectangles whose perimeters are 100, find the dimensions of the one with maximum area. Okay. All right. So we know we want to maximize the area. I need somehow to label the sides of this rectangle. And all I know about it is that its perimeter is 100. If I call this one X, what could I call that one right there?
50 minus X.
Yes. Now, Meg, you're probably going to have to explain that to somebody because somebody's thinking, how'd she do that?
Okay, so the different, so each side, like the X is going to be congruent, like the same length as the other one, so that's going to be X as well. And that'll be 50 minus X. So if you think like X plus, like say we X plus the other, like the different length sides, so that has to equal 50 in order
Okay,
for
so
it to be the same.
I want you guys to think about this for a second. If the whole perimeter is 100, then doesn't the orange piece have to be 50? So if this is X, that one would be 50 minus X, because these two have to add up to 50. Okay, so how do we find area of a rectangle? Length times width. So area equals, if I turn it around, negative x squared plus 50x. Does that make sense to you? What shape is that? It's an x squared with a negative. So it's a parabola opening down, and we want the maximum. So basically we just want the vertex. So you can try to put it in vertex form. I think I'll just go with the formula that's faster for me. So x equals negative b over 2a, so 25. So my parabola has a vertex, and the x-coordinate's 25. Remember this from your notes, guys? This is what you did in your notes. Now, could I plug the 25 into my equation and get the y-coordinate? Yep. Do I need to do that, though? Let's read the question. The question says, what one am I doing? 54. Find the dimensions of the rectangle. Well, isn't 25 this dimension right here?
Yeah.
So what's the other dimension going to be? Also 25. So the maximum area is a square, right? 25 by 25. So the dimensions are 25 by 25. I think that wasn't too bad. Okay, let's look at 57. Okay, we have a rectangular patio that we know is 25 by 40. It's surrounded by a terraced strip of uniform width. So uniform width, that means whatever this is, that's what this is, and this is, and this is. So it's all these, I don't know what they are, but they're all the same. So this is my patio right here. And then here's all the shrubs and stuff out there. Okay? If the area of the strip is 504, so the area of the purple is 504. Find the width of the strip. Well, this isn't a max or min problem, but I do need some kind of an equation. Anybody have a thought? Allie?
Finding the whole area first, which would be 40 plus 2x times 45 plus 2x.
Okay, so make sure you're following what she's saying. She says the area of the whole shape, this whole thing, would be 40 plus 2x, because it was 40 with an x on each side, times 25 plus 2x, because it was 25 with an x on each side. Does that make sense to you? So she says the area of the whole thing would be those two times each other. But would you agree that the area of the whole thing is the area of the patio plus the area of the strip around it? And we know, because they told us that the strip area is 504. And we know the area of the patio is 25 times 40, so 1,000. So would everybody agree there's an equation? So now we just have to figure out how to solve it. So let's FOIL over here. So we get 4x squared plus, okay, now I have no idea if I did my math right or not, so. Anybody match that? Couple, okay. Now, this is not a maximum or minimum problem, so please don't do negative b over 2a. Negative b over 2a is when you are finding a maximum or minimum, a vertex. Okay? All we're doing here is solving this equation. So what are we going to do to solve that? We could do the quadratic formula. You could try to factor it. I'm not going to, but you could try. You could try to complete the square. I think I'll just use the quadratic formula because I have my calculator. So negative b plus or minus the square root. Square minus 4. I could have probably divided out of 2 before I started, but oh well, too late now. I think it would make a fraction there. You could, but it would make a fraction. I actually got this to be a perfect square. it's a big number, but when I square rooted it, it came out to be 158. So it looks like I have negative 130 plus 158 over 8, and negative 130, that won't work. Can't be negative, so we get rid of that one. So I got 28 over 8, which is what? What is that? 3.5. So when I did my quadratic formula, I got 3.5. Feet. And that's the width of the strip. That's X. So that's the width of the strip. Okay, so the first two problems we've done, and one more time, talk about the distinction. If it says, find a maximum or minimum, then we're doing negative b over 2a. Otherwise, you're just solving equations like you always solve them. All right, let's do a couple more here. 58. Oh, thank you. All right, so what's happening in number 58? We're renting apartments. Okay, so this is a kind of an econ type problem. We've got 800 rented at $300 a month. What's our income right now then? Right now, if you're the owner of this facility, what is your income right now?
800 times 300.
Yep. So basically what you're saying, Jake, is that income can be calculated by taking the number rented times the rent per unit. So right now, that is, what did you say, 300? No, what was it?
Yeah, that's the 300
It was
is the
800 is the number rented, and then 300 is the rent per unit. So this guy right now is making whatever that is, 240,000 or whatever that is when you multiply those two together. Okay, but what's happening? The guy's a good businessman. He wants to make more money. So he has observed what?
that is like if he makes the cost go down $5, he'll get 20 more.
Okay, that's a basic principle of econ, right? Lower the price, you're gonna sell more. Now, how many more is he gonna sell? Or
Said 20 more.
20 for every price increase?
Yeah.
So the number of rentals is going up in increments of 20?
No.
Now what is happening to the price?
It's going down
It's going down
5.
in increments of 5. So X represents the number of price decreases. Every time he has a decrease, he gains 20 more customers and he loses $5. Okay, so that's A. That's A. That's your function. They call it R of X. I'm not gonna get all hung up on that, but this is your revenue, your income. All right, so there it is. There's your equation. Skip B, we're not gonna graph this. We're gonna do C. What rent will yield the maximum monthly income? So you see that word maximum, you immediately think vertex. I want you to think about this equation. If you multiplied it out, FOILed it all out, do you see that this would be a negative 100x squared? And a negative x squared means a parabola opening down. And so the vertex is going to be the maximum. So we need to find the vertex. So let's go ahead and FOIL. I really gotta watch my zeros here. They matter, so I don't wanna either gain any or lose any. So I'm gonna count on you kind of checking me. You got a calculator. Of course, I got one too, and I didn't use it, but, is that what you came up with? Now, we want the vertex. Negative b over 2a. What is that, 10? $10 what? $10? 10 apartments? What is that 10?
10 units, like 10 times it.
10 price changes, right? Right? So what does the question say? What rent? Okay, so what was the original rent? $300. We're gonna lower it 10 times. Each time is $5. So the new rent is going to be $250. $250.
So would like the maximum be, would it be like 1,000?
Okay, so the rent that yields the maximum is $250. The number of apartments that we're renting would be 1,000. The maximum income then would be 1,000 times 250. So basically, he's already making 240,000. He'd just be making 250,000, which $10,000. An extra $10,000. Now I do want to show you something. Does this make sense to everybody, Eli?
Where did the negative 2,000 and the 200?
Negative b over
Oh,
2a. That's how we find our maximum. You could also put this in vertex form if you wanted by completing the square, but that takes longer. I want to show you one thing. So we're all good with this. This will work. Use it. I want to show you something that might be a little faster. If you have the factors of your parabola, those give you, if you were going to graph this, which we're not, but if we were, those give us our x-intercepts. So set this equal to 0 and solve it. So 800 equals negative 20x. So x equals what? Negative 40? So you have an intercept out here at negative 40. Same thing here. 300 equals 5x, so x is 60. Your parabola looks like that. It goes through those 2 points. This is the axis of symmetry. What do you think the relationship is between that axis of symmetry and these 2 points? It's in the midpoint. So negative 40 plus 60 is 20, divided by 2 is 10. So that's another way of finding that if you don't want to multiply it out. If you don't want to do all that multiplication, you can use the factors and then find the midpoint of those. For what it's worth. All right, 59. Here we go. 59. Oh, this is the same kind of problem. So see if you can set it up. Only now we're making pop. We're solving pop. So we know that our income is the number of cans we sell times the price each. What's happening in this problem? good manager has figured out that right now he's selling how many right now?
So 26,000.
26,000, and he's selling them for 50 cents each. So I'm gonna put 0.50, you could put 50 if you want to do it in terms of cents. I'm doing it in terms of dollars, so I put 50. But what's happening? This time he's going to raise the price. Now, we all know what happens when you raise the price. The number you sell goes down. Okay, so we're raising the price in increments of what? 0.05x. 0.05. And the cans, the sales are going down by 1,000. So does that equation make sense to you? We want to know, again, I'm skipping the graph part. We want to know how much should they charge to get the maximum revenue. So we need the maximum of that. So one option you have is to multiply it all out. Okay, that's what I got when I multiplied it out. Did anybody else get 800 here in the middle? Anyone? Yeah, thank you. Bueller. Okay, I need the maximum, so x equals negative b over 2a. What's that? What? $8? 8 cans? 8 price increases. And each price increase was worth 5 cents. So I'm increasing my price actually up 40 cents, which means my new cans are I'm gonna charge 90 cents a can. Now, if I charge 90 cents a can, how many am I gonna sell? If I raise my price 8 times, I'm gonna lose 8,000. Am I gonna sell 18,000 cans?
Yeah.
And so my revenue will be 18,000 times 90 cents. $16,200. Did you do that right? So the answers to the question, one question was, how much should they charge? Right here it is, there's the price they should charge. What is their maximum revenue? Right here, that's their maximum revenue. And how did I find the revenue? It was number I sold times the price each. Right? Okay. I need you back at 48. You back at your seats at 48, ready to go. And we'll finish this up. We'll do one more problem and then move on.